Hello guys, this video is gonna be summarized in chapter 3 in bioenergetics on exercise and training, right? So for let's just start by saying that you have three different metabolic pathways in which you break down in which your body breaks down food, which is like breaks down into nutrients, glucose, and all of that good stuff, right? So the first metabolic pathway is phosphagen system, which is best known as the ATP PC system. In this one, you have the adenosine and also a bond of three phosphates, right? So the way that you get energy from the system is by breaking the bond of the three phosphates, which will supply your muscle with the energy that you need to perform the exercise. However, the capacity of this system is very limited, meaning this will last about 10 seconds maximum, right? Then the second process is glycolysis. Glycolysis in the way in which we break down glucose, and we start with breaking it down with two net ATP. The glucose breaks down into into pyruvates, right? And then from there, it really depends whether you have oxygen present or unavailable. If it's anaerobic, it would automatically turn from pyruvate to lactate, right? And then if there's oxygen available, meaning I believe in the mitochondria, that's where the oxygen will be unlimited for it to move on to the Krebs cycle, right? For glycolysis, the enzyme that speeds up the process, it is PFK, which is phosphofructokinase, right? Maybe I said it wrong, but yes. So moving on to the Krebs cycle. In the Krebs cycle, it goes whenever you have the pyruvate already that has been broken down from the glucose. Then from that pyruvate, you get NADH, and then you get a carbon dioxide molecule because one of the carbon molecules will interact with the oxygen molecule, making it carbon dioxide, right? So after this pyruvate breaks down into all these molecules, you get acetyl-CoA, right? From the acetyl-CoA, you get citric acid, and you get some other molecules, which at the end will end up into the oxidative system, and they will go through the process of phosphorylation. So moving on to the oxidative energy system. This system is whenever you're doing high intensity physical activity over to 3 minutes, right? So going back and repeating myself, for the phosphagen system, the activity lasts from 5 to 10 seconds, right? So and then you move into fast glycolysis, right? That is when your body is trying to make energy to perform from 15 to 30 seconds. And then it goes into mixture of fast glycolysis and the oxidative system together. That is when you have activity from 1 minute to 3 minute, and then you go move on into the oxidative when it's above 3 minutes. So each of these have a rest ratio in which it's recommended for you to perform and to rest. So the interval of oxidative energy system, it is a 1.1 ratio, meaning you rest a minute, right? Um, in the production of ATP, so the one that has the fastest rate of production of ATP, it will be of course the phosphagen system, since it's the fastest acting system, right? And then the one that has the greater capacity to produce ATP, it will be the oxidation process for fats and proteins, which is the system that you use if you enter physical activity over 3 minutes. So moving on into substrate depletion and repletion, right? So fatigue is associated with the depletion of the substrates of fatty acids, lactate amino acids, and this happens whenever I said in the like at the beginning that you go from pyruvate to lactate. So whenever you have an accumulation in lactate, that's when the muscle enters into the fatigue stage, right? This usually happens when there is no production of oxygen anymore. So it is more typical for it to happen, the accumulation of lactate in the fast glycolysis and the phosphorylation process than in the oxidative process. There is interval training, the high intensity interval training, and a combination of training, right? The combination of training, to my knowledge, is one of the best. One, it depends on what are you trying to achieve. If you're an athlete, if you're just a regular person exercising, and so on, right? But in the end, all the metabolic responses to training, they can be adapted into what you want to achieve, and what system would you like would you is your goal to use in the different types of training.